Hello there, and thank you for joining us for this practice set on complex numbers lesson 1. If you are looking for the practice set for complex numbers lesson 2, make sure that you click over to that because this would be the wrong lesson. Please like and subscribe if you find this video helpful. Drop a comment, ask a question below, and check out the other videos and playlists on the channel. So as always, pause the video to work these problems on your own and then come back to check your work. Right, so these first ones are, first of all, like reviewing how to simplify square roots, but also getting used to what do I do when I see a negative under the square root. Now, there's different strategies for simplifying square roots. I'm going to try to review a couple of those. Now, one of the strategies that I use when I teach how to simplify square roots, because it converts well to other kinds of radicals, is to do prime factorization. So with the number 20, we might factor 20 into 2 times 10, and then we might take that 10 and factor that into 2 times 5. And so we might do this. We could do 20 is 2 times 5. And then because it's a negative 20, we want to make sure we have that negative 1 in there. Now, this is a square root. So when you are simplifying a square root, you are going to look for things that are squared. So we have 2 squared right there. And the square root of 2 squared is just 2. And then I also know that the square root, well, I guess I could do this. I could say negative 1 is I squared, and the square root of I squared is I, and that leaves me with the 5 that is still under the square root. So we weren't able to get the 5 out. So that's one way you can do it, especially if you struggle with simplifying square roots, if you're not comfortable finding perfect square factors. This is a great strategy. It's almost foolproof unless you mess up the prime factorization, which can happen. But now for this one, most people could do this without using a calculator or without factoring. This would be the square root of 16, and then because it's a negative 16, we have the negative 1. So it's the square root of 16 times the square root of negative 1. Square root of 16 is 4. Square root of negative 1 is I, so it's 4i. I would probably go straight to the answer because I've been doing this a very long time. Don't skip the steps until you're very confident about it. Okay, with the 72, you could go for the biggest perfect square factor. Okay, so one way of doing this one is to look at it and say, hey, that is 36 times 2 times negative 1. So you would have the square root of 36 times the square root of 2 times the square root of negative 1. Square root of 36 is 6. Square root of negative 1 is I, and that one's still there. Now, a lot of students will miss the 36. It's just kind of a big number. So I will see a lot of students get like the 9 and the 8, and they're like, oh, the square root of 9 is 3, but there's like another perfect square in the 8. So if you wanted to do this with the prime factorization, you can do 72, and then this is the one that a lot of students will catch. They'll say, okay, that is 9 times 8. 9 factors into 3 times 3. 8 factors into 2 times 4. And then we've got 4 factors into 2 times 2. So the prime factorization is 3 times 3 times 2 times 2 times 2. And then I guess we could say the negative 1 is I times I, if we wanted to. And now we're going to look for perfect squares. So we see a 3 squared, I see a 2 squared, and I see an I squared. And so the square root of 3 squared is 3. The square root of 2 squared is 2. The square root of I squared is I. And the only thing left under there is the 2. And 3 times 2 is 6. Okay, so both of those methods work. If you are like, what is she doing? Check out my video on simplifying square roots. I'll see if I can link it. I'll see if I can link it up here. I'll kind of put that like a reminder to myself to link it up there so you can go check that out, and that'll give you kind of a deep dive just into that skill, which you can then integrate the I into without too much trouble. All right, these two were meant to be side by side. We have the square root of 25, which is 5. Don't overthink that one. That one really does not have a negative in it. And the square root of negative 25 would be 5i. And this one is to drive home the idea that when you are taking the square root of a negative, the I pops up in the answer. You don't have to overthink it. You can do this out by saying it's 25 times -1. So we have the square root of 25 times the square root of -1. And that's where the I is coming from. But it literally is always going to come like from the -1. Anytime you have a negative under the square root, you're going to have that -1 to factor out, which is going to generate your I. So you don't have to think through all those like little pieces of it every single time. Now, the next round of problems are simplifying the higher powers of I. Debatable, like whether this is a super useful skill. Now, you might remember this from the lesson that like I to the first power is I squared is -1, and then we kind of work through these. I to the third is -I, and I to the fourth brings us back to 1 again. And what you could do is recognize, okay, well, like that's a pattern. So I to the fifth brings us back to I to the sixth is -1. So I to the seventh is -I, and that would be fine. Okay, so we have I to the seventh is -I. And you could probably do that for the I to the 15th. I mean, this is not going to take us like a super long time, and just kind of figure out. But if somebody were to make those numbers much bigger, like 622, we do not want to have to go through all of that. So a faster way to do it is to take that exponent and divide it by 4. Okay, and that's just going to get all these like groups of 4 out of the way, so we can figure out what's left over. So 4 goes into 15 3 times. 3 times 4 is 12, and the remainder is 3. So I to the 15th is I to the third, which we know is -I. And then for the 622, we definitely want to do it that way. So for the 622, we've got 622 divided by 4. 4 goes into 6 1 time, and we subtract. 4 goes into 22 5 times. 5 times 4 is 20. Then we have another 22, so it goes in again. And we have 2 left over. So that means you've got 155 groups of 4. That are in that 622, and then you have 2 left over, which means this is equal to I squared, and I squared is -1. Now, there are other ways you can do that. I use long division because I was taught that in school. I know a lot of younger students are not as comfortable with long division, so you might do something like there are groups like 25 groups of 4 in 100. So you might say, okay, I'm going to get rid of a group of 4. Groups of 4, and then more groups of 4, and that's going to eventually bring you down to 22, and then say, all right, well, from there I can subtract the 20. Like, you can reason it out that way. Just make sure that whatever you're doing, you show what you did, and if your teacher asks you, how did you generate this too, then you could say, well, I understand that like there are groups that 100 is like a nice even group of 4, and I just kept subtracting hundreds until I got down to 22, and then I just did it with a smaller number. You could say, 622, you could subtract 400, the boom, and that brings you down to like 222. So lots of ways you can reason that out. All right, so these ones are meant to go side by side just to show the contrast, so solving these. Now, the one on the left, you can actually solve that multiple ways. So you can solve that by recognizing it is the difference of squares, and you could factor it, and then apply the zero product property, okay? And so subtracting 3 from both sides, we get x is equal to -3, or adding 3, we get x is equal to 3. You could also solve that this way by adding 9 to both sides. So x squared is equal to 9. Take the square root. You just got to remember that slick little like plus or minus. So the square root of 9 is 3. So you can get the positive and negative 3 that way. Okay. You can also use the quadratic formula, but I'm not dragging you through that right now. This one over here, though, not factorable, that is the sum of squares. You can use the quadratic formula, okay? That will work. Maybe we'll take a look at that here. But you can also do that by subtracting the 9. And now we actually have the tools for handling that. But same deal, you want to take that plus or minus. So we have x is equal to plus or minus the square root of -9, which we already know is 3i. And we did look in the lesson at how that would play out. Now, if you wanted to use the quadratic formula, your a value is 1, your b value is 0, and your c value is 9. So you could throw that in. Okay, so here we go. The opposite of 0 is 0. Love that. 0 squared minus 4 times 1 times 9 all over 2 times 1. So what do we get there? We get plus or minus the square root of 36 all over 2. Negative 36, because that was a minus. Plus or minus the square root, so that'll be 6i over 2, and 6 divided by 2 is 3. Would not recommend that way, but I mean, it'll work. All the tools that we have in our toolbox. Okay, well, that is it. That was a short little review. Please like and subscribe for more math help. Drop a comment or a question below. Check out the many other playlists and resources on the channel, including part 2 of complex numbers. So to round out all the things that you never knew that you wanted to know about complex numbers, be sure to check out that second video, and I hope to see you in a future video.